All right, so we're joined from Athens, Ohio, at Ohio University at the Russ College of Engineering, Professor Dr. Neil Littell, graduate of Madison Central High School, Holmes Community College, Mississippi State University.
Yep.
They're now as a certified manufacturing specialist, project manager, really one of the authorities on technological advancements in manufacturing. We've got a room full here with us at Velma Jackson High School. It's our computer science engineering class, and we're recording this for all of our friends in Madison County schools, at the middle schools, high schools, and our YouTube channel. And we thank you so much for joining us. And like I said, we've been really talking about robotics, and that's a big push in the district on robotic education, robotic functions, robotic technology, robotic trends, and how that is really changing the face of engineering from so much. But before we get into that, let's tell us a little bit about your educational background, because we were in high school together at Madison Central High School, and then going from there.
Yeah, sure. Thank you, Greg. So it's a pleasure to be here. I love doing this type of stuff. So thank you for inviting me. It's such an honor to get to engage with you and your fabulous students. So yes, I grew up in Madison. I went to Madison Central with Greg. I then went to Holmes Community College for 2 years. I got an associate's degree in drafting and design. And from there, I went to Mississippi State University. I majored in industrial technology, which that program, by the way, does have robotics. They have at least one robotics class. I've seen their robotics lab, pictures of it. And so that might be a really good option for you if you're looking to continue this pathway into robotics and automation, which is absolutely massive in the manufacturing environment today. So went to Mississippi State. I worked for the university for about 4 years, and then I went and worked for a Mississippi company. You may be familiar with Viking Range. And so I started working with Viking Range in 2008. I still work with Viking Range some. And so I've worked with them for quite a long time. I really enjoy working with the people over there, and love the products, and the environment over there is really nice as well. And in 2014, I was able to pursue my dream of becoming a university professor. So here I am in Athens, Ohio. A little bit different than Mississippi, but the people are still really nice here, so it's all good.
Yeah, up there in the Midwest, I know it gets way too cold for me, but Athens is a great town. Now, like I said, we've been looking at and we've had all these engineering guests, all these scientists and things, and one thing that we really try to stress is that these careers are really going more technological based, going more engineering based, more robotics based. And it doesn't necessarily mean you have to have the PhD. You don't really necessarily have to have the college degree. Like yourself, you went to Holmes Community College. They could find great careers with that associates with drafting at Holmes Community College right up the road in Ridgeland.
Yeah, and actually, so that is a little bit of a funny story about that. So that degree is what really pushed Ohio University to hire me.
Wow.
Because they wanted someone. I was hired to teach our product design class, and they wanted someone who had deep experience in drafting and design. And so even though I had a PhD, that was the degree that mattered to getting me the job here. So
yeah, and that's important, because when you look at, we looked at your webpage and looking at some of the things that you specialize in, these companies are not looking for, the trade jobs are always going to be there. There's definitely tradespeople needed,
sure.
Especially when you're talking about heavy manufacturing. Ingle Shipbuilding here in Mississippi desperately needs welders and iron workers, but they really want people to figure out how to make things efficient. They want people that can work with new software. They want people that can work with products that make products, because it's about time, it's about quality, and it's about money. So when it comes to manufacturing and these careers and these skills, what skills are you seeing that are most needed when it comes to these engineering graduates?
So two skills I'll highlight for you. Number one is problem solving. So being able to analyze the situation, understand what's going on, and propose a solution that makes sense is something that is really desired. So you have to understand when you go to college, and you get a college degree, what you're telling an employer is, I was committed enough to show up every day for 4 years to do difficult things and to push myself to do something greater. And through that process, I was able to learn how to think and make decisions and execute. So that's number one. Number two is communication. So being able to not only analyze the situation and come up with a way to make it better, but then communicate that concept back to the organization to really implement a solution to fix a problem. And really, I mean, that's what we're trying to do here, right? We have to solve problems, and unfortunately, companies seem to have more problems than they have solutions, and that's why they're really wanting to have people who can think, not necessarily with a degree. I mean, it could be a 2-year degree as well, right? But someone who can think, implement a solution, and communicate with the team about the solution that you want to implement and why you think it will be effective. We're seeing robotic solutions being pushed because there's been tremendous advances in robotics over the last decade. We're seeing vision systems being applied to robotic solutions, so these robots can actually see what's going on. They're starting to be able to be more intelligent, and you're seeing collaborative robots as well. And what that means is you have robots working next to people,
yeah,
in safe ways, so that if a robot runs into a person, it's smart enough to know, hey, I hit a person, I need to like not knock them over, I need to get out of the way, right? And so you're seeing a lot of really cool capabilities that are coming about. You know, like at Viking Range, for example, is a good example. We took the porcelain coating for our oven cavities is all automated now. So back when I started working in 2008 at Viking, we had this big, is basically like a big clean room almost. And the people who are doing applying the porcelain to the steel, they are basically wearing like a suit, right? So because they can't breathe this powdered metal, right, or this powdered porcelain that they're applying to the metal, and so that process is now completely automated, and so we were able to improve the working conditions for those individuals as well as increasing our quality through implementing a robotic solution. And those are the kinds of things that we really strive for. So not only improving the lives of the workers, so now we can move them to doing value added tasks is what we would call it. So if we can automate a task, then we say that's not a value added task anymore. So now we want to move that person over to adding more value in some other place, right? And so when you think about products and the speed at which companies have to launch new products to remain competitive in the global marketplace, there's a ton of emphasis being put on new product development, launching new products with advanced features and doing really really amazing things. And that is only accelerating. I mean, back when I was a kid in the 80s, think about Greg, this will maybe resonate with you better than your class, but think about the number of cars that were on the road. Just like there was I don't know, maybe 50 different vehicles you could pick from. Now you have like hundreds of cars that you can pick from.
Yeah, and on top of that, when technology changes, the manufacturing process has to change as well.
Right.
And like you said, stuff is becoming automated, but you still need people to run that automation. The skills that are needed coming out of high school and college now have changed since we came out of high school and college.
Absolutely.
Now one thing also is that even and you mentioned that the people are working with the robots. And it's not, I'm trying to think how to word this. Like even here at Canton, at Nissan, they have the robots there, but they're doing things that maybe need to be more efficient, to be more powerful. Because robots can be more powerful than a human.
For sure.
And then on top of that, if people are wanting more technologically advanced stuff, you got to have a more technologically advanced process. Now, and I ask all of our guests this all the time because I think it's important, because we know with high, and I think I can speak for all the teachers that'll see this, is a lot of these kids, we start doing a project, oh, this is too hard, I quit. When it comes to engineering and anything technological and manufacturing, how often do these engineers get it right the first time?
Rarely. So what we do is we de-risk. So that's what we try to do, and we de-risk through using technology, right? So we run simulations, we use math, we really try to set ourselves up for success by de-risking that prototype. And the way that we do that is through using all of the tools that we have available to us. There's a ton of computational tools. And the other thing that I'd like to say is the tools are getting easier and easier to use. So don't think that implementing a robotic solution requires a PhD. It doesn't. If you have the persistence to get in and watch YouTube videos and get access to a device and start playing with it, start programming it, don't be scared of it. You would be surprised how far you can make it, just on your own by doing that. So yeah. I really don't want you to feel like you have to be, some brainiac to be able to be effective in the role of being a robotic technician or a robotic solutions provider or a robotic implementer.
Yeah, and now we have the robotics and engineering program over at the Madison County Career Technical Center, which our kids can take a part in. And they also have the engineering academy over at Ridgeland High School, which is really giving them those skills, and they're getting to be able to get certifications coming out of high school. So a place like Viking Range would be more than happy to have somebody with the robotics experience at 16, 17 years old. They could probably find a spot for them immediately.
I believe so. Yeah. So I mean, there's a lot of opportunities. I mean, the job market is really hot right now. And we talk with manufacturers all the time, and this is one of the things that we repeatedly hear them talk about is the workforce, training the workforce. And so we one of the things that's exciting about living in Ohio right now is Intel is building a set of really large plants in Columbus, Ohio. They'll be the biggest, most expensive manufacturing facilities in the world when they go live. And they're telling us, we don't need people with 4-year degrees. We need technicians. We need people with 2-year degrees. We need people who can do the work. Guess what the average salary is for that plant, by the way?
I would guess pretty good.
6 figures.
I would say about close to 200.
I don't know if it's that high, but it's north of 100.
Wow.
And so you're talking to somebody that is a technician, right? So someone who has a 2-year degree, can solve problems, can communicate well, and can contribute to the company, can solve problems.
Yeah, and I just got a couple more things to talk about before I get to the students' questions. And this is two things that I think our students need to know, is that also going the military route to get into engineering is also very hot right now because of the state-of-the-art technology that these people are working with, especially like the Air Force, Navy with their radar sonar equipment, and the way they have to work, the engineers on vehicles and computers. That route is also extremely lucrative coming out of the military, getting into manufacturing.
Right. Yeah. So we have Wright-Patterson Air Force Base, which is kind of like the epicenter of Air Force activity in Dayton, Ohio. I'll be going there tomorrow. I do a bunch of work with the Air Force, and the Air Force is actually in the middle of a digital transformation giant project. So you can Google this. I mean, you can look up the DoD, the Department of Defense, digital strategy, and so it's published in 2018. And so we're doing a lot of work in transitioning a lot of the programs over to state-of-the-art digital tools, and really sort of helping expedite their ability to execute, really. So a lot of sustainment activities, so making sure that we have stuff that flies, it can fly, and it's not sitting on the tarmac out there. Because if it's not flying, it's not adding value. So we want to make sure that all of our assets are in the air as much as possible. But that is a great point. The military is a great way to get structure to your life. I mean, I work with college students, and sometimes I find people who just can't seem like they just can't get motivated, and a lot of times that lack of motivation is a symptom of a lack of structure in their lives. And so the military will help add that structure to help set you up for success. Personally, when I have a struggling student, one of my advisees, I tell them to do two things. So this is if you take away nothing from this presentation, take away these two things. If you want to fix some problems in your life, eat a reasonable diet. Like not just like green stuff that was alive at one point, not processed stuff, right? So like vegetables and fruits and things. And number two, get on a sleep schedule. Just wake up at the same time every day. Every day. That's the weekends as well. If you do those two things, you would be surprised at how many problems that will solve in your life.
Yeah. Now, the last thing I wanted to hit on before I get to the students' questions is, obviously, in the last few years, there's been a big initiative to diversify these STEM fields, and there is a lot of opportunities for women in these fields, and there's a big push to get more minorities in these fields as well. So, what have you seen as far as those trends to really diversify these areas?
I'm so glad you brought that up. So I serve on our diversity, equity, and inclusion committee here at Ohio University and the Russ College. So I serve with I think 11 members from my college, and that's out of I think no, it's not 11. I'm sorry, it's around 8 people out of 77 faculty members. I think 77. And so what we're trying to do is really look at our student population and understand the dynamics of diversity and what we can do to bring in more female students, in particular in engineering, and also more minority students. And so, we look at our landscape here, and we have challenges with diversity. We also have challenges. I think one of the reasons that I love doing this for Greg is, especially helping our young women engineers, our hopeful women engineers understand what engineering is about. When you grow up, you know what a teacher is, you know what a fireman is, like all these career paths, but a lot of people don't understand what an engineer is. And so engineers solve problems. And if you want to have a big impact on the world, being an engineer is a great way to do that. So we don't just sit behind a computer and crunch numbers all day. We don't do that. If you want to get if you want to use your hands, we have a lot of ways that you can be out there doing stuff with your hands, especially if you're working in robotics. That's another exciting area for robotics, is you can have kind of a blended life where you can work with your hands some out on the shop floor, and you can also come back and do some stuff on the computer. So that balance is really nice for a lot of people. But yeah, so really just helping people understand that engineering at its core is about solving problems, not about doing really difficult math. And I think one of the misconceptions is that engineering is too hard for me. Yeah. And everything's hard for you at some point. I mean, think about growing up as a kid. Walking was hard, but now you walk, right? Running was hard at some point. So everything is hard for somebody at some point. It is a mindset to understand that you're good enough, you're smart enough, and if you push hard enough and you're persistent enough, you can be successful.
Yeah, and engineers have solved some of the most important problems and done some of the most, like, for example, I love the movie Hidden Figures. If Katherine Johnson, the flight engineer, we may not land on the moon. So that was, extremely important engineer that took her figuring out how to do the rocket propulsion. So obviously everybody's not solving a problem that big, but that's a huge example of an engineer that solved a huge problem.
Absolutely.
I do have some questions from the students. Get to as many of these as I can. This is a good one. This is Nakasha James, she's a senior, one of our basketball players here. And she asked, what piqued your interest to get into technology?
That's a great question. So I would say my family. I mean, I have 2 uncles on my mom's side who went through the same program that I went through at Mississippi State. And I got to see them working and what they were doing, and I thought, that's kind of interesting. That seems kind of cool. Maybe I should investigate that career path as well. And so I'd hear them talking, and just the cool problems that are problems that I thought were really cool that they were solving. And so that just sort of kind of attracted me in. And the other thing was, I had sort of somebody to talk to, right? If, I felt like if I got stuck, I had kind of a safety net. And one of the things that you should know also about going to college is a little bit different than high school, in that, being a professor, we love to engage with our students. I mean, we are here to help. And so if you feel like you're getting stuck, you're not alone. You are definitely not alone. So, but you have to have the courage to ask for help. There's opportunities, and there's a ton of infrastructure that we build at the university level to help support our students, but you have to be the one that has to have the courage to say, hey, I don't understand this. Can you help me understand it? And yeah, so we're all kind of a community, and we all stand on the shoulders of other people, right? I mean, I wouldn't be the person I am if I wasn't able to stand on the work that other people had done before me. And I'm hoping that I'm a stepping stone for other people, my students, and as they go off and do great things.
That's awesome. And I love this question here. This is Brian McMurtry. He's a senior as well. And he asked, what questions do you ask yourself when you are improving machines?
When I'm improving machines?
Yeah.
So it depends, right? So if it's a new design, I'm talking a lot about requirements. What does this thing have to do, and how's it going to be measured?
Yeah.
Right. If I'm improving an existing machine that is not working correctly, I need to understand, what's not working. Is it a subsystem of the system that's not working, or is it something else, or is there a business process or some other process? Is it an issue with the raw material? Is it an issue with training with the people? Are they using it incorrectly? Is there a maintenance issue? So is there a calibration issue? So you kind of, after time, you kind of develop this kind of like mental checklist that you start to go down, depending on your application and what's going on. So that is a great question, and that takes practice. And the only way you're going to get practice is to do stuff.
Yeah. And obviously, with the changing technology, those questions are going to change every time.
Sure.
Now, here's a good one. This is Catherine Johnson. She's a junior.
Okay.
She asked, do you believe that robots will have more jobs than humans in the future?
Oh, that's a great question. I don't think so. And the reason is because I've seen robots do really dumb things, and I think, as a human, so much of our society is based on human interaction, and robots are not to the point of being able to replace those human interactions. I mean, even ChatGPT and other AI softwares. I mean, if you go to ChatGPT and depending on how you ask things, I mean, it just makes stuff up that sounds correct. Yeah. And it's like, okay, well, I saw a thing on ChatGPT last night where a student had gone to ChatGPT they wanted to find citations for a research paper that they had to write. So their thought was, I'm going to ask ChatGPT to identify publications that then I can go acquire and read and then write my paper. So they were sort of like kind of reverse engineering the paper, I guess. And so they did. ChatGPT generated these citations, and when they started looking for the citations, they realized they were completely bogus. Like these publications don't actually exist, right? And so I think that there's a place for robots. I think you're going to see robots take over monotonous, simple tasks. You're not going to see robots doing super complex things. And that's where we're gonna really rely on people to still make decisions about things. I see AI and robotic solutions as assistants to people, and and I think that's the capacity at which they're going to stay. I mean, I could be wrong. I mean, it's been known to happen before, but but that's kind of what I see. And you never know what's going to happen in 20 years, right? So that forecast is good until about 2035. We'll say that, and then it expires.
This is Kayla Page. She's a sophomore, one of our volleyball players here, and she asked, "What is some of the coolest materials you've worked with?"
Coolest materials? Oh, I can show you some actually. I'll be right back. It's like right over here. All right, I'm back. So this is a powdered metal. I don't know if you can see that or not. And so I'll put a little magnet on here so you can kind of see kind of how it works a little bit. So what we do with this stuff is I'm trying to get the light to not be a glare on it. So what this came from, this is a titanium alloy, and it does have some ferrous material in there, which is why it's magnetic. But what we use this for is additive manufacturing. So basically 3D printing. This came from what's called an SLS machine, so a selective laser sintering machine. And so what happens is we lay down a bed of this really fine powder. The particulate size is very consistent and very small. And then we go in with a laser and basically melt the powder metal together, and we print like layer after layer to create very high quality, very strong, very complex geometry parts out of this powder metal, right? And so, and then another magnetic type material is this stuff, which is called ferrofluid. So it is I don't know if you can see it, but it is actually a fluid.
Wow.
That is magnetic. It's a ferrous oil, and applications for this include adaptive shocks. So in your vehicle, so if you have a vehicle where you can make the suspension stiffer or softer, and some of the suspensions are using ferrofluid to do that. So they're manipulating the magnetic field.
Magnetic fluid.
Yeah.
That is incredible. All right, I just got one more from the students. This is Carl Tavius Ross. He's a senior. And he asked, what's the biggest challenge you've ever dealt with on a project?
Oh my gosh, the people. I cannot say that. So see, I mean, seriously, I laugh, but really that's it. I mean, and so I run our Masters of Science in Project Management, and in project management, we talk a lot about the technical side and the people side, the soft side of project management. Personally, the most difficult project that I've ever managed was at Viking Range. We had a project which was called the speed oven. So we took technology from one of our sister companies, Turbo Chef, out of Dallas, Texas. And so if you've ever been in a Subway or a Starbucks, they have those little bitty ovens that sit in the back that cook stuff really quickly. That's called a speed oven. So it uses a combination of technologies in there. One is microwave, so it has a commercial microwave system in there. It has a normal oven technology in there, but it also has what's called high airspeed impingement. And so basically you have jets of air that are blowing from the top and the bottom really fast, up to 60 miles an hour. And we can control those air speeds. And so if you know anything about thermodynamics, that's a great way to transfer energy. And that's why those ovens are speed ovens. So we had a project at Viking to build a residential speed oven, wow, which was the most complex appliance I've ever seen in my life. We don't sell them anymore because they were a bear to make. Everything about them was difficult.
That just sounds like a fire hazard waiting to happen.
Well, no, not a fire hazard, but so and that's actually an interesting point. So, but that it could be a fire hazard, but you mitigate it. And so mitigate means you reduce the impact of, and the way that you mitigate it is through the controls. Wow. And so this oven, and you didn't tell it what to do, you told it what you were cooking, and it would cook it. And so we had we had like a big catalog of food, and you would tell it what you're cooking, and it would set the parameters of the oven so that it cooked it perfectly.
Wow.
Each time. And that's why when you go into Starbucks or Subway, they turn around, they only hit like one button. It's because it's pre-programmed to do its task.
Wow. That's incredible.
The really cool thing about that oven though is it's smokeless, and that's why you see them in Subway and Starbucks. So we use we have if you know what a catalytic converter is.
Yeah.
So we have basically had a big catalytic converter in the back. So a big screen coated in platinum, expensive. And that platinum will react with the smoke and absorb it. So you could have these sitting in a commercial restaurant and not have a vent hood, because Starbucks is very particular about their decor, and they wanted the ovens in the front where it could be quick for them to work with, but they didn't want a big hood hanging down with all the noise, and it's kind of ugly and all of that. And so that's another great example of materials being leveraged for a purpose. But those ovens have about $500 worth of platinum in them.
Wow.
Just to give you an idea.
Yeah, that is too expensive to make. Well, we're almost out of time, and we thank you so much as always for joining us. But before we go, tell these kids why they really need to look into these engineering jobs, and why these industries need them.
Yeah, great. So being an engineer is fun. Your days are different every day. You have different problems, different people, that you work with. So the job is dynamic, right? And if I really like the challenges, I really like seeing the result of the effort and the projects coming together. So like I enjoy looking at appliances that Viking Range makes that I had a part in, I had a part in that thing that is being used at wherever, and so there's a great deal of joy there. These jobs are they're high paying, I would say. You can also pivot, and what that means is if you become an engineer and you decide you don't want to be an engineer anymore, it's pretty easy to get a different job, because if you got an engineering degree, that means a lot to a lot of different people. So let's say you want to go into sales, right? Go be a sales engineer. They make a ton of money. Yeah. So because because a lot of sales engineers get paid a commission, which means they get a percentage basically of what they're selling. And if you're a sales engineer, that means you're selling something that's technical and probably very expensive.
Yep.
Which means that you're probably getting a good commission off of each one that you sell.
Yeah, and then you could be in civil engineering, you could pivot into electrical engineering. So it really is a much broader field than people realize.
Yeah. There's different flavors of engineering, and they do get very specialized after probably after the sophomore level. So you could start in some engineering and pivot into others. Some of those are easier than others. So for example, chemical engineering is pretty easy to pivot into biomedical engineering.
Yeah, absolutely.
And then like mechanical engineering and aerospace engineering, you see those go together a lot as well.
So just so much cool stuff. I mean, we could talk about it all day, but again, thank you so much. Dr. Neil Littell, Russ College of Engineering there in Athens, Ohio, Athens University. Go Bobcats.
Thank you very much, Greg. It's been a pleasure. I love doing these. So please let me know when I can come chat again.
All right. Love to see it. All right. Thanks, buddy. Talk to you soon.
Thank you. Bye.